On October 29th, 2025, it happened. The interstellar object 3I Atlas, the third we've ever seen, reached its closest point to our star. And at that exact moment, it erupted. Its brightness doubled in speed. Its gas production soared 40 times higher than before. But the expected dust cloud, the inevitable signature of any comet, completely vanished. It was a physical contradiction. Whatever changed inside Atlas that moment, experts could not explain. This is the story of the day our models broke, and a mysterious object revealed a secret forged billions of years ago. The first sign of the anomaly wasn't a flare, but a single number flashing on a monitor. On the night of October 28th, the automated data feeds from the space-based solar observatories, Stereo A, SOHO, and GeoE19 all caught a sudden, steep spike. The light curve of Atlas had shot up to an r to the minus 7.5 power slope. That number is critical. It means the brightening was nearly twice as fast as any model predicted. This wasn't a gradual warming. This was a jump. Carl Badams at the Naval Research Lab was the first to post the alert on the team's Slack channel. Comet has jumped off model. Minutes later, Chi-Chang Jiang in Taiwan cross-checked the SOHO images and confirmed it. Within an hour, a global network of astronomers was in a panic, poring over the raw data. They were writing the playbook in real time. They had a precise timeline for the moment Atlas activated. The obvious answer was a massive ejection of ice and dust. But the more they looked, the more the obvious answer dissolved. The light curve told them Atlas was venting. The spectrographs told them what it was. The Swift satellite's UV detectors caught the chemical smoking gun, a massive surge in OH emission, hydroxyl radicals. In comet science, OH is the direct proxy for water. It meant the object's water production rates had suddenly jumped to 40 times their previous levels. Atlas was not just reflecting light, it was spewing water vapor into space at an incredible rate. The data was clear. This was a gas-driven event. But there was the contradiction. In every known comet, gas bursts dragged tons of solid material, dust, off the surface, creating a spectacular red tail. The explosion of gas should have created a visible debris cloud. But space coronagraphs like SOHO and Stereo A showed something else. A large, elongated, smooth coma. It was glowing with a blue-green color, a hallmark of gas-dominated emission. The classic fan-shaped dust plume was absent. The outburst was massive, the gas was surging, but the dust was missing. Atlas was dumping billions of tons of water vapor, yet acting as if it were a rocket engine burning clean fuel. Why would an object built from ice and rock shed all its volatile gas without shedding any of its dust?
The search for the missing dust led the James Webb Space Telescope, the most powerful instrument ever built, to look deeper. And what it found was a shield, a shell, a geological nightmare forged not by the sun, but by the galaxy itself. JWST's near-spec instrument found evidence of a crust on Atlas, an outer shell 15 to 20 meters thick, nearly 65 feet deep, that was chemically distinct from the interior. This shell wasn't just a surface, it was the mantle forged by billions of years of cosmic ray bombardment. As Atlas drifted through interstellar space, high-energy protons and heavy ions relentlessly slammed into its surface, converting carbon monoxide into carbon dioxide and destroying or depleting the ice below. The crust that formed was tough, dark, and highly processed. It acted as an armor plate. This solved the contradiction. Atlas's outburst wasn't triggered by surface heat, it was triggered when the sun's heat finally penetrated this thick, radiation-forged shell. The internal ices, the water, the carbon monoxide, suddenly reached their vaporization point and the pressure built up. The gas escaped through fissures and cracks, but the thick, tough mantle of processed dust-poor material remained mostly intact, holding back the solid grains. The massive object was encased in a shield sculpted by cosmic history. The mystery wasn't about a lack of activity, it was about a delayed activity. The discovery of the ancient crust gave the scientific community a plausible explanation, but it also birthed new competing theories. Some experts believe in the carbon dioxide cooling cap model. A frost layer formed near the surface, acting like a giant insulator until the sun stripped it away, causing the explosion. If this is true, the surge should coincide with the depletion of CO2. But then there are the radical theories, the exotic nucleus model. This argues that the object's internal structure, perhaps due to a non-natural design, crossed a threshold that abruptly switched on its activity regardless of the slow buildup of temperature. This predicts perfectly symmetrical outgassing and even non-natural radio signals. The radiation process crust model, supported by JWST, predicts that as Atlas moves away from the sun, new volatiles from the deep, pristine core will start to emerge. We should see a distinct chemical change. The only way to know the truth is through pure open data. As Atlas fades from view, only a brief 8-week window remains for Earth-based telescopes to gather the post-perihelion data. Astronomers from Mount Aya to La Silla are in a desperate global sprint, bypassing traditional delays, sharing raw files and calibration scripts in real time. They are racing not just to solve a puzzle, but to set a new standard for open science, because the answer is out there, and it will be found by sharing. This is where the story shifts from cosmic mystery to an urgent global human effort. With Atlas already fading from view and the critical window closing, just 4 to 8 weeks before it slips back into the void, the astronomy community has unified like never before. They realized no single lab, no single nation could solve this colossal puzzle alone. The call for data transparency became a roar. Astronomers pressed NASA and the European Space Agency to release the raw, minute-by-minute packets from the space observatories immediately, instead of the usual proprietary delay. And it worked. A global observation sprint took shape. Teams from Mount Aya to La Silla are securing time on every available telescope, while amateur networks set up rapid response alerts. They are sharing target list, calibration script, and even raw files in public repositories. Radio astronomers are listening at custom frequencies for anything that suggests an engineered source. Spectroscopists are making direct comparisons between the pre- and post-perihelion data, hunting for the chemical shift that would either confirm the deep crust model or reveal entirely new volatiles. The science is messy, the window is tight, but the goal is clear: to test every single one of those rival hypotheses. The world's astronomers are racing not just to solve a mystery, but to set a new standard for open, collaborative science. Because the answer is out there, and it will be found by sharing.
But even if the dustless eruption is explained by the armored crust, one terrifying question remains. What is at the center? The radiation-forged shell is a record of Atlas's interstellar journey, but not of its birth. We are only looking at the shields, not the core. The planet seed idea, put forward by some, suggests Atlas is not a comet at all, but a planetary building block, a remnant from the violent formation of an alien world. If true, its interior would be layered, dense, and compositionally distinct. Deep imaging and mapping could theoretically reveal these impossible-to-classify internal features. The truth is, even with the JWST data, we are guessing about the core structure, its density, and its rotation. It carries an estimated mass of 33 billion tons, half again as massive as Halley's Comet. Yet we know less about its interior than we do about our own moon. It's a cosmic time capsule. The material sealed beneath that 20-meter shield has been untouched for billions of years, a pristine sample from a star system light years away. It holds the chemical record of an alien star's birth. Will the ongoing data sprint reveal a dense, layered core that supports the planet seed model? Or will it reveal a structure so unique, so perfectly designed for survival in the galactic void, that it forces a reevaluation of every hypothesis? The final chapters of this story are not just about explaining the past. They are about predicting the future. Because whatever built Atlas, whatever it holds at its core, it is coming from a system far more advanced, far more ancient than our own. On October 29, 2025, Atlas showed us the incredible power of a crust forged by billions of years of interstellar travel. Its sudden dustless explosion proved that our understanding of interstellar visitors is decades out of date. The truth is locked in the next few weeks of data, and we are all about to find out how far our cosmic frameworks have to stretch to handle what's coming next. If this story of cosmic activation and missing dust captivated you, hit the like button. And if you want to be the first to know which of these three competing theories, the cooling cap, the exotic nucleus, or the galactic shield, is proven true, subscribe. The true nature of 3I Atlas is still an open question.